Okay, so as you can see, we have this patient for the liver analysis. We have different studies, but really is the same. This is really for kidney, so we are going to use this for liver, and also we will use this other study that was made like a month and a half later, because in this case we will be able to see the bile that has a very nice contrast enhanced, so we will have a very nice view of the bile. Let's start with this. We have three series for this study. We have the arterial one, so this is arterial phase, very early stage with contrast. We'll have the portal, very nice visualization of the portal vein, and the supposed to be equilibrium. No, this is different. This is the portal, and this is equilibrium, because I have a better viewing of the portal veins, the suprahepatic hepatic veins. I will have a better extraction for those than here. Okay. So with control or caps, I can select all those studies and then abdomen liver analysis. We need to identify, when we have different phases of the same study, we need to identify which one of them is each one. So here we will have the artery, that's fine. This could be the portal, I think this one is portal. I have here, the downside here is, and I didn't record the numbers, but anyway, I will say this for portal and this one for equilibrium. And now the first step will be the extraction of the liver. Okay, the extraction of the liver will be done in a reference series. We can use whichever I want. I can use the equilibrium or the portal, whatever I want, but by default it will try to use the equilibrium, or if I can launch this application with just one phase if needed. So we can use the series we have. In this case we have 3, and later on we will request the other study. But if I rather have the portal extraction, I can do it, and this will be the reference plane. In this case, we will see that more or less the extraction, the painted in green region, will be more or less okay. Oh, sometimes I hate my mouse. More or less seems to be okay. Everything is green, looks like liver. Yeah. So I will leave this as it is here. And then we switch to registration. I can use it any phase I want. So if I would want to extract it in the artery, I will extract it. But just for you to know that the extraction used will be the reference plane for the registration. Okay, so for example, in this case, if I use the phase, the portal phase, and then I switch to registration, this will be the portal, there will be the lower image, and now all the registrations that are going to made are going to be done as the base image will be the portal, and the other phases are going to be twisted and modified to match the image of the portal phase. Okay, so for example, here we have the late artery, and then in the late artery superposition, we have here this coloring. We have that we see some double lines here that tells me that the patient didn't get the exact amount of air in these two phases. That's normal. So I will perform a non-rigid registration. Okay, when I do the non-rigid registration, the software will deform the artery phase to match the liver shape of the portal phase. Okay, so it also tells me to ignore the vessels. I always let this check, because sometimes the vessels may tap the vessels in the liver, as in the lung, are quite close. The arteries and the veins or whatever, so the portal vein, and are quite close. So if they are enhanced, let's say so, it can overlap this. So this is important to check this just for the registration to work correctly without overlapping of structures. Okay. Well, now when it's finished, we will have a correct match, a correct superposition. The other structures may not match so good, but the important part for this will be the liver. Okay, I can just go front and back to see that everything is correctly. And I need to repeat the same with equilibrium phase. Okay, just again, start registration. For the registration, I always use the non-rigid registration. But if I use, instead of two CTs, for example, and I get an MRI for one MRI-CT study, then I won't use the rigid registration, because in the MRIs, they used to have just the part of the body that they want to take the images. So in the case of the cholangiopancreatography, you will only get that part of the abdomen, so you won't have you will only have this maybe lacking the front part of the abdomen, or the back part of the abdomen. You will have only the part where the bile duct and everything else is. Okay, so in these cases, for MRIs, you cannot use the non-rigid registration, because it will distort too much the images and will not fit correctly the shape of the liver. Okay. Okay, in this case, I will load another related image, but it's another CT. It's not an MRI, so I will get this other study. So this is the previous one, day 22 May, and then I will select this. And now, again, as you can see, if I just try to set the non-rigid registration, it may work. Okay, it could work, but I prefer always to get the things as easy as possible to the software. So I will try to modify a little the things to match somehow the structures. And then after this, I will say, okay, that's more or less okay. Let's try again. Let's try now the non-rigid. So I first try to modify the software, so the location of the overlapping series, to be easier for the software to get a correct match of the images. Please, if you do this kind of overlapping, the registration between the series, will appear this as the format image included. So here, for example, if I go to another series, everyone that has been modified will appear with this advising of the format image included. This is nothing to be worried, but it's something that doctors sometimes say, oh, what's this? What's the meaning of this? This just means that we have performed the non-rigid registration, and then the image has been distorted to match the portal phase. Okay. Now, surrounding organ extraction. One of the settings is that we can make that all extractions, or almost all extractions, to be made automatically. Let's continue. I will show you the screen a bit later. And here is it. Here is where you set what extractions are going to be done automatically at the start. Okay. I have everything set in on, but the bile duct. The bile duct, I usually set it off, because unless you have a study with a nice view dilatation of the bile duct, you won't be able to have a good extraction of it. Okay, you can try it. It may work somehow, but if you don't have a good study with a nice viewing, the extraction will not be good enough. So for demonstration purpose, I have this set it off, and I just show manually how to extract it. Okay. You can see that the extraction, you can have this is the inferior cava beam, so I can displace to check out if the extraction is good. Used to be good enough, so that's fine. And we can also say the arteries and the portal vein. Maybe the portal vein is not so good. No, I mismatched the series, don't worry. So here in this case, I will switch to portal maybe. Oh yes, here, sure. Yeah. Yes. So let's go to the portal. I prefer this series to extract the portal, I think, because this is, I have a better view in here in portal. I will extract again. Sorry, let's set in auto and extract. Sometimes it tends to extract in equilibrium phase, but it's not the better. Much better right now. And in the equilibrium phase, we will have a better view of the hepatic veins. Okay, so I will have the hepatic veins, I will have the portal vein, I have the arteries. Regarding the arteries here and all the other vessels, I will be able to manually extract or modify the extractions already made. For example, here, I will just put it bigger. I will be able to maybe just click or with this tool from one point and indicate the trajectory of the vessel. And if possible, the software will try to continue in that direction to add more parts of the vessel. But it's always limited by the thickness we are working with. So if we have a very small thickness like this, we will be able to have somehow some small vessels, but otherwise it will be impossible for the software. I can try it again. I can cancel and try it from this point, maybe. I have more luck, and I can continue the extraction of some other vessels if I want. Just say for this, maybe, etc. Of course, I can do it by clicking, as we did in the lung resection analysis. So, for example, here I can add the vessels by click here and here and here and here and switch my planes and continue extracting. And when I'm happy with the result, just set the diameters and set OK, start extraction, and this will be added for the extraction of my vessels. Also, I can delete. The delete tool is more often used. I can draw a ROI or just click in one point here, and you will see as all the rest of the vessel will be deleted. But in most cases, I use it to here, for example, to delete some branches like the spleen one, and delete some other branches. I don't want them to appear. This is okay, so I will leave this one. And when I'm done, let's go to the bile duct extraction. For the bile duct extraction, as I didn't set it out to automatically extract, if I set it to automatically extract, it will try to be extracted in the main phases, but not in the related ones. So I will need to switch to related CT, and now we will have the extraction. We will need to, if I try to make the automatic extraction, it may fail. So I just will try to set it, and you will have something like this. And this is because the software always tries to search the bile duct for a fatty tissue. So it's going to look for lower densities here. And this is why I have something like this. This is not correct. This is not right, because in this case I have contrast inside the bile duct. So I will delete this. So I will change here and just delete everything. And now I will do it by this with this tool. So I can just come here. I can do this with any plane. Let's put this bigger. And from this point and in this direction, the software will try to find the bile duct. Still, the result is not good enough. It's not bad, but it's not as good as it could be. So I will use for this case the vessel extraction by manually adding to the extraction already done. I can just click and drag and drop, so it will add something. Ah, by the way, importantly, by default, these extractions always delayed. Let's say it gets bigger by 1 voxel. We have it here. So it had a dilatation of 1 voxel here. I recommend you to set it to 0. So otherwise, when you have fine structures or fine vessels, it will grow too much. Okay. So now I will just add some other branches here or there or whatever. So I will have a more detailed extraction of all the bile duct of the stud. I don't like this, so Ctrl Z to go back. Okay, more or less, this is fine enough. I could also manually add some other branches by click point by point and adding some other branches, but for this study is good enough. And then we will extract the tumor. For tumor, we have two different colors and identifications. One is the high tumor and the other is the low tumor. The high tumor will be the tumors most likely malignant that have some enhanced by the contrast. Okay, so we'll have higher density. So this means really higher density tumors, like for example something like this. On this will be lower density tumors. So for example, maybe things like a cyst or whatever the liver may have. Okay. So for this case, I will just set the diameter here like something like, let's say this. And here is it. Okay. As always, if the extraction is not good enough or I don't like too much, for this point, for this case, I think is good. But I can modify it with the other tools we have seen before. Okay, I can use this, for example, to say, okay, I want to delete some part of the region because I don't think that this is part of the tumor, so I can drag and drop to remove. I have this to remove or whatever, so I can modify this. I don't know why it's not they are not disappearing. Oh, I have this in vessel, but anyway, it's not disappearing, and it should. I have this. We have selected this, and then I can delete. That's fine. Oh no, now it's doing. Okay. I don't know why it didn't before, but now it's working. Okay. Of course, gone with the undo button, I can just go back the last steps to undo the modifications. Also, the gallbladder can be extracted, but by fully automatic extraction. So we won't have any tools or automatic tools because have so many different densities or let's say different things. So here we will need to extract with the standard tools we will have here. So for example, for this case, I will extract it like if it were a tumor. Okay, so if I just click here, I can set that this could be the starting point, and then I will go to the end of the gallbladder, and the software will try to extract it somehow. Here is it. Okay, so when we have done extracting, we have the possibility to extract as well the skin and the bones on maybe other structures. So if you want to extract spleen or stomach, whatever else, you can use these masks to add more layers, more extractions of the result. And then we switch to the observation tab. here it will ask me the starting of the vessel. This automatically locates it. So I will be automatically located for hepatic veins, for portal vein, and also for the artery. So the artery should be somehow like here, most likely. And here for the bile duct. Sorry, I mentioned it before. For example, if I want to disconnect some paths, I can do it here. And if I click one point, this will be disconnected. This is a very small point, but as you see, there is some discontinuity between this and this. Okay. And now if I set root here, you will see that this part remains in yellow. This line remains yellow. This means that it's not connected with the rest of the extraction I have already made. And if I apply this, the software will warn me, telling me that okay, there's something disconnected, and this will be discarded. So this will be deleted if I don't connect it again. Okay. So for this case, I can just undo if I want to, or try to connect path. So I can just click from 2 points, which ones are going to be connected, and now, yes, everything is connected again. So I have the root here, and everything will be connected. In some cases, you may find, mostly in the hepatic veins, that they have some additional vessels or supplementary vessels going out from the cava, and these in some cases are not connected, and you need to connect them. You can set the root in one vessel or just connect those paths with the cava vein. Okay, so just for your reference. Well, I apply, and we will have the result. Sorry? Yes, yes, yes. Because if you cancel, you don't set root, so you cannot segment regarding these vessels. But in this case, some tools doesn't allow you to make extractions like the bile duct. And here is it. Here is the result. One thing that I want you to take in account is that the bile duct visualization may vary a lot regarding your configuration. So that's why I have set this to monotocally decrease it, this one, because otherwise it gets sometimes too big. If it's estimated by a diameter from image, or for keeping image, if I said just for you to take the image, I can apply. So this is maybe too big. Maybe it depends on the extraction you may have, or also for the estimated diameter from image. So if you don't have a good extraction, we do have a good extraction for this study. So this you can use whatever you want. But if you have one study that has not a good extraction, it may appear really, really big. As you can see here, it may be, I can hide some of the organs. So I will hide the vein, arteries. So we will have this. As you can see here, this is quite big, okay? And this is why sometimes what my recommendation is to set it by default in monotacally decrease it. So we will have a thinner vessel for the bile duct, okay? But let's go back here. So the extraction will be more natural, to say so, okay? Okay, here, as happened with the lung, we will have the possibility to have this the visualization of the surface display. So we will have, or just the extraction. So we will have the visualization of the voxels, squares here, nothing that any doctor would like. The surface display, the cut plane, we'll come back to this later, and also for the observation of the plane around the region of the cut plane. But here, the extractions will be slightly different from the lung. Basically, it's the same. So the doctors will need to planify the extractions to see what parts of the liver they do need to cut. Okay? This is basically the same. So at the end of the day, it's more or less the same as they have in the other application. Is what they are going to look for in this other. I will hide the gallbladder. Okay. But they often need to planify the surgeries depending on the size and location on the tumor. So here we will have this, and this will be used more often than it used in the other application, the lung. But also is not really often, very often used. For example, in this case, when I select this tool for extraction with the scoop region of this tumor, just to clicking the tumor, the software will extract the surrounding organ, and in this case, for the upper part or somehow some part of the region. Of course, as you may take a look at here, this is a shape completely strange and not the one that any doctor will want to have. Okay, to modify this, just select again this, and then you have to modify the orientation of the liver. So if they want to extract for this upper right side of the liver, will be modified to match this orientation. So now this arrow, so where is this scoop region looking for? This will be this part I have selected from the orientation of the 3D. Okay. It will give me, as always, the volume and everything here. So we will have the total volume of the liver, the rest of the liver after this resection, and this scoop resection here. Okay. Okay, this is one of this is what by default is teached in the standard trainings, but we are not in a standard training. So let's delete this because I don't like. So I will just delete this region. I don't want to have this. And let's go for, as always, for the vessel extractions. Here we will have the possibility to select, for example, the portal, and the target of the region I'm going to extract will be like the tumor or will be the vessel. Okay. For example, if I extract the tumor here, now it will look for the vessels that are at some distance, had happened before with the lung, the vessels that are at some distance, in this case 5 millimeters away from the lesion. Okay, so we will have some more or less the same that the doctors will look for. So this could be somehow interesting for them. Okay, not as much, this is not really practical, but this will be some more or less practical, because in this way I can say, okay, this will be transparent. I can see the cut plane here. And when I see the cut plane and display the vessels, the doctors can hide the tumor or set it transparent at least, and they will know what they want to cut and from which vessels. In the case of the liver, the segments of the lung, so the liver, sorry, will be calculated from the portal vein in most cases, and they will need to know from which part would be the region they want to cut, because they want to know what part of the liver is tributary to that exact vein. Okay, so in this case, if I come back to this tool, if I just undo this and just select this portal, it is going to tell me that these are the branches that will be cut. This is the point that will be cut to have this kind of extraction, as well as some others like this branch of the segment 4 that looks like segment 4. Anyway, so this is more something more like of the appearance that the doctors will look for to make that kind of segmentations. But still, they want to combine this with another, as well as happened with the lung resection. We'll have the possibility to add a new operation. So we will create a new different one, and here we will have the possibility to have this or the sections. If I click on sections and start the extraction, the software will automatically create the separation of the segments of the liver. Okay. For the ones who doesn't know the anatomy of the liver, maybe some one of you there, I will have this in presentations, abdomen. I have in liver analysis. This is shared with you. We will have this. Those are the segments, but it's not the best. I think it was a better one. It's not here. Oh, no, it's not. I thought there was a better image than this one. We have the segments. The segment 1 is close to the cava vein. Then is segment 2, 3, 4, 5, 6, 7, 8 is like a clockwise identification. So it will be, somehow clockwise. But the segment 4 has really two sides, two parts. Is the segment A, the upper part, and segment B, the lower part. Okay. So anyway, this is something that many doctors would look for when they are planifying their resections, because they want to know what region is tributary to one portion of the liver. But in this case, for example, we will set these segments will be here, and I will set them to opaque. So we will have this segment 1 is this, segment 2, 3, 4. 4 could be divided into 4A, 4B, and then 5, 6, 7, 8. Okay. This is done automatically. This is something that you just click here, portal, and see this in section. It's done automatically by the software. You don't need to do it by your own. By difference in the lung resection, when you have to do it clicking in the branches, you don't need to do that here. You just click in here and click in section, and it's done. Click here, portal, and then section. Okay. And here you will see in colors which branch of the vessels will be included in each region. So these two branches will be for region 2, segment 2. This one will be for region segment 3, sorry. This one will be segment 4, etc., etc., etc. Okay. So for this case, it's most likely that this patient will need a partial resection of this upper right part of the liver. So most likely, to demonstrate this case with decementation of the sections, and then make translucent this part, the segment 8, and maybe the segment 4. So I can just segment 4 also transparent, because it's part of the segment 4 will be included within the lesion. Okay. This will be the one part the doctors would need to resect. For this case, I will then go one step more. Maybe to make a demonstration, this is enough. Okay, because the doctors, okay, this is good. This is one I want to see, to how to resect this and which vessels are going to be shown or here or there or whatever. But I also want to add another step, and is this. With this tool, we can merge two regions. This is the same tool we saw in the application of the lung analysis resection. So I can select just two segments and join them in just one of them. Okay, this is for merge two segments in just one. But this other one is another different. These are the operation methods, mass calculations. As you can see here, you know the Boolean algebra. Some of them you know. Well, Boolean algebra is used mostly in mathematics and in informatics, and allows you to have different regions and have some combinations. So I can have what is not in one area or the other, add what is in an area and other, subtract one area for the other, the intersection of both areas, or what is not in the intersection of those areas. Okay, this is something a bit complicated, but for trainings, advanced training, this is nothing I will show in a demonstration, okay? But in advanced trainings, I do show them this. In the second session I do for liver training, because some cases like this one will be nice to have some other parts. For example, in this case, segment 4A, that will be the upper part of the segment 4, I will just delete, hide everything else. I will hide everything here. Not to be shown another. Now I will my that out. Everything will be out. And here I will just show you the segment 4 in translucent way. So segment 4 is this central part of the liver, and you will see that the regions for segment 4 will be the ones who part from this stretch. Okay. So for this case, I will just select this to create a new region. Okay. I will just click here, and we will have this region will be displayed in blue, and is this upper part. Maybe I will need to add some other branches of the blue of the segment 4. It depends on up to the doctor. This is up to the doctor to add some other parts of this region 4, because this is just to calculate the exact region segment 4. So in this case, I can continue to set portal and then add some other. I don't want to add this, so I will cancel, delete this point, and select this branch, and maybe this other two. I need to extract. Let's go back to this. I will need some zoom. Okay. I will add another one. Let's say this. This is quite tricky because sometimes if I click in this one, it will be overlapped. It depends on one do you want or do you need to extract the branches you need to go adding or not. But for this case, I will set it just for here for this, and I will combine this other. As you can see here, the name are S1 to 8 because are segments. Okay, so these extractions I have made by my own clicking on portal veins. I will see portal vein 2, portal vein 3, etc. So this, I will combine those two. Let's say the combination with this merge tool has to be done with just by one. I cannot combine 3 in just one click. So I have to combine first these two, another the next two, and now this will be merged together. And if I want to add this other one, I can click it here. So I will have this, the purple with the good one. Oh, sorry, it's this. Okay, so I have now my segment 4A. 4A would be this upper part of segment 4. This will be more or less okay because it's touching my lesion, everything is fine. And with these tools, I don't want you to complicate it too much, but for this case, what I'm going to do is to have the segment 8, segment 8, and in addition to this gray one, is I will add it to the segment region portal vein 5, and instead of create a new one, I will overwrite the portal vein 5. Okay, so when I execute this, I will join the segment 8 with my segment new, and this will be the real resection that is going to be made by the doctor. So this is really the liver volume and everything that is going to be extracted from that point of the vessel. So I will here, and you have so many of them here, this is too small. So, and there's no clicking here to get it out. I will drag and drop. But I cannot. Now here's Okay, so this, instead of this, I will show this in transparent or whatever. So I have this segment 4B, I have this other segment A, extraction 5. These others, if I don't need it anymore, I can delete it, because when I use this, it never deletes me. It still saves me these regions. But if they are not needed anymore, I can delete them. So I can just delete them if I want to. So it will just set me for segments and portal vein 5. And now I can just, if I just want to show again all the rest of the segments of the liver, I can do that. But the thing is that this way you will be able to extract exactly what you want, what the doctors want at the end of the day. So then this is in the liver, as in the lung, is quite complex because it's usually planified regarding the vessels, regarding the veins. Some cases, instead of the portal, usually is the portal vein, the one they use for the extractions. And some other cases is suprahepatic, but it depends on the approach they are going to do for the surgery. Okay. Of course, when I have this, sometimes it's quite useful to display the cut plane. So we will have displayed where it's supposed to be cutted. Oh, this is curious. Yeah, this as we have extracted all the segments, there is nothing left to show. So this is why is nothing shown here. So this is why sometimes doesn't work as expected. But doesn't mind. We can show this where this will make appear, let's say, a space between the extracted regions. I will set them to opaque to show them. Uh, Here, if I set this, the segments are not exactly regions, so this is why it doesn't appear. But you can modify here the space between the segment and the rest of the liver if you do so. Okay. So this is somehow how they, at least how they have told me they plan the surgeries. Okay, to be honest, this I have made trainings for this mostly in Castilla-La Mancha, where we have a very large installation in SESCAM, and I have done trainings for liver in Albacete Hospital and Guadalajara and Ciudad Real, etc. And most of them tell me that they want to know exactly which vessels are inside one of these regions, and exactly know what's here and where do they need to cut. Okay, so this is really what they expect of this kind of application. But it has some other uses. I don't know if they are really practical, because when I have shown to the doctors, they have plain be quite indifferent. So, but also we have some things like, I will delete this just to show. We have some other things like, for example, in vein or in porta, we can activate this to have the possibility to see what region and what vessel are in that region. I will hide the veins again to show you, and also the artery. This is practical because this shows you which vessels are included in what region. And this is something that doctors, they do find practical. So this is good to have. So that's fine. Let's go in portal, or not just portal. You can use it in vein or whatever, but if it's hidden, you cannot see it. So this is somehow practical. But there's another one that is this one. Sorry, it's not. I close this. Oil. This is just for measurement. So this way they can measure from one distance from one part of the vessel to the other. So this tool is okay. But also there's this search vessel arriving tumor that I will need to uh, switch back to portal to normal. I have everything here. So portal shown is here. And with this tool, switch vessel arriving tumor is supposed to appear a color coding mapping. Oh, I don't know why it doesn't appear. It's shown. It's there. Let's say with this, with the show additional information, it's more or less the same. Here we have some color coding, but this is telling you some kind of volumes of which branch and what volumes of the liver are having each one of them. But this can be also modified here in the settings. In the settings, I can switch. Where are you? Here in the reliability settings, instead of distance to the volume rate. So we will have which branches has more volume of the liver. Still, I haven't found any doctor to find this kind of tool practical, at least for the moment. Maybe in the future they say, oh, this is wonderful because this and that. But so far, this additional information regarding of the vessel selected, it doesn't tells them too many things, but it's something that is there. And finally, we have these other tools to also create regions by segmenting manually. This will be a completely manual segmentation. For this case, for example, we can create a segmentation 3, and let's say that, for example, in kernel, I can create an ROI or just plain. More or less, the functionality are the same. And here I will have the possibility to resect manually, set some regions. This is more or less okay. And here that is bigger, I will create a bigger one. So as you can see, it's going to be interpolated. Another one, I can draw again if it's too slow, too small, sorry. And finally, continue again. Now, let's say something like that. Okay, if I extract extraction, I will be able to create a new region for this part, and we will have it here. This is now very much different from this scoop thing, so really it's not needed. The good thing with this is that sometimes if I have different extractions, for example here, when I have this extraction 8 with all the, I will change the color here because otherwise in gray is not visible. So I will edit here and change the color to something brighter. Let's say orange. Okay. Make it translucent. It's here. So this is my automatically created with the segment 8 and 4A. And here, if I want to add or delete some parts, for example, let's say I want to add some other part of the right portion of the liver, I can create it, for example, with this tool. Let's say again in coronal, so I can create now region here. I'm just doing on the fly to, let's say something like this until here. Okay. And if I create extraction, it allows me to override the selection I have here. So in this case, the PV5, if I add this, if I overwrite it, this green, orange region will be deleted, and this will be the one that will remain. If I create a new one, it's more or less the same. If I add, it will be combined, this region I have drawn with the existing one. Okay, this is another way to create or combine some regions, but you need to have them seen here, and then you will be able, for example, segment 4, I will need to be drawing some ROIs in the middle of the liver to create manually a segment 4 and extract it by modifying this region. Okay. Okay, so the rest of the application more or less is the same. This is just for matching the visualization of the tumor within the inside area. So if I, for example, I set this for opaque or transparent, this should be, this segment 5, the one should be modify accordingly. So this is just to the display state of tumor and region should be together, should be applied together. The rest is more or less the same. This is to create some presets of the names of the segments, but it's not really needed. This is more useful in the lung, so you can create segment 1 to 10 if you want to. But really, this is more or less everything. Finally, we have this sector MPR. The sector MPR is not. For sector MPR, I used to extract at least the skin because otherwise it just gets to nothing visible. Here, for example, I can make visible everything here, so I can put it opaque or translucent or whatever I want. And here I can double click in any point to create a virtual transductor. I don't like this view, I prefer the measurement view. So the lesion will be the target. I can move this for any point I want. I can move it here with the cross viewing to select the target. I'm going to set. And this transductor, or this kind of, supposed to be ultrasound transductor, will be able to be moved around. And I can also switch it to one direction or the other and rotate it as much as you want. Okay. If I get the cursor close to these circles, I will be able to rotate it. Sorry. Oh, now I can rotate it. This is tilting, let's say so. This is rotating. Okay. And finally, in the center will appear a square that will allows me to move around and set the position in the skin in the liver. If I don't have the skin here, because I don't have extracted it, the double click will locate this kind of transductor directly in the surface of the liver. Okay. Maybe if it's an intraoperatory planification, that's good, because sometimes they use the ultrasound directly in the liver tissue, but just in case they are just planifying a function or whatever, they can do it with the extraction of the skin. Okay. And you will have the distance to the target, so they will need, they know the how long will be the needle, etc. But this is something that is for experimented surgeons. This is nothing that they will use at all. But maybe for some residents or some teaching purposes, this could be enough to show them where to locate the transductor and the orientation they will need to have the kind of image they will want to have this visualization. Okay. This. Correct. Correct. Yeah. No, here in the general, here you will have, if you want the liver, this is where we start, remove the surrounding organs, only volume. Yeah. Here, you can select the volume. So if you select the volume, all the organs and vessels will be extracted and subtracted. So this volume will be just parenchyma. Will not include the tumor, neither the any other structures we have extracted. Okay, so this is just liver parenchyma.
Question about button. For this kind of extraction, like say, also bile duct, etc., you need to know how to read the TP image and the anatomy very well. If some things that we can use in order to understand the I have some people when we call them say, I don't know, set to the initial point or something. I always afraid to
This is a concern that has been shown to me by some doctors. For example, here there's a hospital here in Madrid, Puerta de Hierro, that they do have concerns about the result of the extractions of segmentations we are doing here. And their concerns is that they have find that sometimes They have one provider here we have one provider here in Spain. It's called Cela. Cela is a kind of ethicon. It's more or less the same business model, or more or less the same way of selling the product. And they have Cela agreements, so they have some cases already done in per year. And they have found out that the results of the vessel viewing and extractions and segmentations done by this software, this Cela software, like could be name it Ethicon if you want. It's not the same, but more or less, are more precise, are more accurate than the reportings of the radiologists in the hospital. So they are afraid. I have made the demonstrations for them, and they say that we are not completely sure that this extraction you are showing to me is 100% accurate. It's 100% precise, because we have found out that even the image can cheat on you and can, you know, uh, be not really real for real what is inside the patient, because their own radiologist has failed in some cases. And I couldn't argue against that, because this we have the FDA marking, we have the CE marking, but nothing else. The thing is that behind Cela, I don't know with Ethicon, but I am afraid that it's the same. There's a doctor, there's a radiologist that is verifying all the extractions and verifying that all the segmentations are exactly correct. We are not. We are just trusting and feeding the algorithm of extraction of the software with deep learning and a lot of additional studies. It has improved a lot. I swear, I can tell you, because I have seen this from scratch. From these extractions was like shit. So, and right now it has improved really, really, really much. The extraction of the vessels and everything is really good. And one thing we do quite automatically, and they do love, is the extracting the segmentations of the portions of the liver. This is something they do really like, and they find that, of course, we can find that some cases are complicated ones, because the porta has some, you know, misformations or whatever, and the segmentations may be crazy. Really, I have some cases, but they have. I have found out that some radiologists have been, because when we have shown this is mostly in Ramon y Cajal Hospital, and they find that the extractions are really good. But when the doctors, the surgeons, are not so confident with that, it's difficult to argue with them. In this hospital, in Puerta de Hierro, the thing what I said to them is, I won't see what Cela has. So I don't show me the result of Cela. Just give me the same study you give it to them. You give them the study, give me the same study, and I will just do what automatically my software does. And you will compare. You compare the results of software of Sinus 3D against the Cela extraction, and the Cela extraction will be verified and modified by a doctor, by a radiologist, but my one is going by default. So they still have to compare. Yeah, I was going to visit them last week, but they have an emergency transplant, liver transplant, so I had to cancel. I expected to show you and tell you, no, this is so great that we can compare with a doctor extraction, but I can't so far. So I cannot tell you that really this is 100% accurate. I cannot tell you that at the moment, but I expect to have good results, because I will show you just the study of that patient. I will show you this for here, and I will, so yes, this one is this case. This is the patient they gave me, and this is the result. At the end of the day, I think it was not really a complex case, not so difficult case. But they was not afraid. They were not afraid that this extraction will not be accurate. But really, the extraction will be done automatically. The vessels and everything was quite fine, with just a couple of series, just artery and portal, because I didn't use the late phase, because I didn't like it that. So I didn't use this, just the arterial and portal phases. And with that, I was able to show, to extract everything here, and also the bile duct. The bile duct is something that is, in some cases, is complicated. And in this case, it was not so much. Even so, I had some MRI cholangiography here. I think it was some of those. I don't remember. But the extraction was so bad, and the visualization for the CT was good enough here. I have good enough visualization here. You can see the bile duct here. It's really easy to see in this case. It's these fatty parts there. So the extractions were so good. So I didn't modify anything. Just this is the result. Still, I need them to check out and compare this with the other vendor, but I have good expectations. Okay. Sorry, I cannot be more precise at the moment, but I expect to be in the future. Nothing else? But yeah, but the thing here is that maybe the what is displayed here as bile duct is here the fatty part that is painted in green. Maybe precise, maybe, or maybe not. We are not 100% sure. I'm quite sure, but anyway, I can sign nothing else. Yeah, but the vessels are so big enough and the extractions are good enough to trust them. So really, maybe the bile duct may be good or maybe not. I think it's good enough, but you know, uh, I will show this to them, and I'm quite sure that maybe the cella extraction will be as well very good for sure. But we don't know how many times the doctor or the radiographer or whoever did the extraction and segmentation worked for that. So maybe they spend 2 hours, maybe more, because we have this software in another hospital here in Madrid, in South Madrid, and they use it for segmentation manually done. All verified, they are done by radiographers and overview by radiologists. And they print everything and they send this to many other doctors in Madrid for planifying their surgeries. And they told me that this is precise, this is correct. And to extract this, they have to spend at least 1 hour, one very skilled, there really are two really skilled radiographers that are very accustomed to work to extract veins and vessels and modify whatever. So they're really skilled, and they do the extractions with our software in 5 minutes, maybe less. And with any other software before they bought our solution, you spend like 1 hour per study. So they say that really is good, really works great. I trust it, but you know, I cannot sign for for you. This 100% precise, because it also depends on the study, depends on the thickness, depends on the contrast. Is it too late or too early? Are too many factors that may affect to the result that we cannot be 100% secure always. But really, the result is quite impressive to see in when you make demonstrations and you just get here liver extraction automatically, registration automatically, you just come here automatically. Then now here I have this case, you know, I have here the cholangioprotectomy study, you know, the cholangio. And here I realized when I came here to extract the organs, and I extracted the in the phases, equilibrium phase and the related MRI, the result was better in the portal. The best result for the extraction of the bile duct was in portal phase, and the vessels was much better in the equilibrium phase or portal phase or whatever. Was really good. So really, you know, I trust the result. The structures of the vessels, the anatomical variations, mostly everything that will be extracted is at least good information for doctors. 100% secure. I will never say that in front of the doctor, but inside this meeting room, I will tell you that it is really great extractions. More questions, please.
Um, occasionally, they only have MR liver. They do not have CT. Because we don't have MR liver analysis to check spread of when pathetic. Um, how do you do that?
In these cases, I tell them, let's check out this. We can do liver analysis just for MRI. So, for example, in this case, it just said this MRI is crap, so it's very bad. I will be able to use this, so it's not good. Well, let's try this. And we have liver analysis, but all extractions will be much more poorer, worse than we will have in the other here. Oh, I hate MRI. Sorry. I hate MRI. Yes. Yeah, it's 100% manual. So yes, yes, yes. In these cases, it will be quite difficult. You will have a good visualization here, for example, for a bile duct, but vessels will be almost impossible to work with 3 millimeters. For God's sake, possible. But anyway, if you is the only thing you have, you can give it a try. So the instructions are completely manual. So you have to go like in the first all days when I started to work with this application, drawing the ROIs here and there, and etc. So I will extract this inferior cava vein, and let's say start extraction. This is my cava vein, and then extract whatever I can. No automatic extractions, all manual extractions, etc., etc. For my point of view, if this is the only you may have, because sometimes the user, the patients, only have this study, or they bring a CD or whatever, and it's the only thing you have to struggle with this and do it everything by hand, manually. Is not the best use case, but it's the one you have. What you can do usually is to load, if the patient is inside the hospital, you have connection with PACS, you can recover any other study, any CT. With a abdomen CT, you can try to extract it, because almost all extractions, at least of the portal, because almost every abdomen CT will have contrast, you will have a good extraction of portal veins and the porta and the hepatic veins and everything. So you will have a good extraction of that, and then you can combine that with the MRI. But is only if you may have maybe even an old study of the patient. If there's some pathology, of course, you have the pathology only seen here, only displayed in the MRI, you will have to extract it here. You won't be able to extract it from a CT or previous CT or whatever, because maybe in that CT was not existing that tumor or whatever. So you will need some extractions in switching from the MR and the CT images. But at least the extraction of the liver and the vessels, if you have a contrast study of the abdomen, CT one, you will have a better result, and much more quicker, and without so many manual modification, that you will have with the MRI.
Because in quite some cities in different countries, now the patient, especially for colorectal metastasis, liver cancer, and then they only do MRI. So they only have MRI.
If there's nothing previous, you have to work with this. There's nothing else you can do.
I think it triggers the different approach, right? I think it's not a lot. Trying to see how you can availability with that MR when you have got which is like it. So there's a lot of integration.
Yes, that's the thing. The thing here is you have interpolation. But if you come here to observation, this is what you have. But if I say to this, you will see the 3 millimeter steps of those. If there's nothing else you will have, Yes, 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 yes. Of course, it depends on the accuracy of the study of the result of the study will depends on, of course, in a good image. If you don't have a good raw image, something to work with that is good enough, you will have to, okay, I will find somehow things more or less like that, more or less like the extractions I'm trying to make here. So if I here extract the bile duct or extract the portal vein or whatever, so I can, okay, let's give it a try to find something in this direction. It will fail for sure. But anyway, if I get to manually extract the vessels of everything here for the portal, for the hepatic veins, for the bile duct and everything, and then I get here I have some kind of interpolation, but of course won't be the one any structure smaller than 3 millimeters won't be there. What was something that is your up to your interpretation. It's not something really seen or really displayed there. So that's the point. You cannot 100% trust this. It's more an orientation of how to get into the surgery, what's the better approach, but we will lack many, many real information that we will have with CT with thin slices. Is the way it is. Something else? Sorry, I cannot be more precise than that. The thing is, in not many countries, they do just MRI. For example, here in Spain, it's more often to have CTs than MRIs, than just MRIs. So for most patients, you will have uh, more because the MRI has a lot of waiting list already. So to overload with some patients that with studies that the image quality and the result will be equal or better than MRI for just the location of lesions or for this kind of studies is not so often. So here in Spain, is more often used the CTs than MRIs. Maybe that is why FTYO is still not a priority because they find that okay, this is something good to have, but it's not really needed worldwide. It's not the best solution yet, but it's how it is. In Japan, it has to, prioritize which is better to develop when in one time, and maybe that's not a prioritization.